Good morning. I just want to, and run. Hello. Good morning. We're looking at polynomials today, or yesterday, or tomorrow. I don't know when you're looking at this, but you wouldn't be looking at it yesterday. Anyway, so polynomials, you've dealt with them a lot. Please don't stress. Some of the language is different, but it's 10A is pretty solid. So let's have a look. Ignore this until you get to it. State whether or not each expression is a polynomial. Well, this is really simple. We've done this before. If everything's just whole number powers of x's and no negative powers of x's, so for example, this one, x is 2 and x is 1, then that is. But this one, x would be negative 2, so that is not. This one, well, that x is a half, so that's x to the negative 2. This is x to the half, so that is not. This one, well, it literally says 2/3. By the way, just a reminder, if I have x to the 2/3, then that's the cubed root of x squared. That's not. Here, the x is to the 2 and the x is to the 1. So it is a polynomial. Here it's 2 to the x. Now with polynomials, it's only ever x to the something, or j, m, whatever. But it's not 2 to the x. That's not a polynomial. This one is because we've got whole number powers of x. Doesn't matter that the whole thing's over 4. We could have separated that to have 7x to the 13 over 4 plus 3x over 4. That one is not. You have not seen those yet. Don't stress. This one is all of the powers of x are whole positive numbers. This one is because it's x to the 0. It's just not a very fun polynomial. And this one is not because x is on the bottom. They're fairly simple. Now, we have some terms here: the degree, leading coefficient, leading term, constant term, and whether or not it's monic. We have some weird stuff going on here. And I'm going to work through every second one of these, starting with 2b, because hopefully you'll start with 2a. So we've got so for I, the degree. Now, the degree is always the highest power. So for this one, let's actually have a look. This one here is x to the 0. And this is x to the 1, and that's x to the 3. So our powers are 0, 1, and 3. So the highest power was 3. For number 2, the leading coefficient is always the coefficient, the number in front of, the highest power. So here it would be -6. Okay, number 3, the constant term, the term without an x, or with the x to the 0, that's 10. 4, what have I missed? Leading coefficient, leading term. Oh, okay, so 10 was the answer for 4, sorry. 10. The leading term would have been -6x cubed, because it's always the biggest power of x. Finally, for 5, they're saying whether or not it's monic coefficient of leading term is 1. So no, because our coefficient was -6. I'm going to have a go. I'm not going to do D, but I'm going to do F. So for this one, we have to actually expand this before we can figure out any of these. So this equals x squared times 1 is x squared. X squared times x, negative x to the 3 is take x to the 5. Negative 3x times 1, take 3x. Negative 3x times negative x to the 3 is plus 3x to the 4. Now we can start answering these questions. 3, 4, 5. So, question 1, the degree, the highest power of x. Well, the highest power of x is 5. Number 2, the leading coefficient. Well, the leading coefficient is always with the highest power of x, so that's minus, what do we do when there's no number? 1. The leading term, minus x to the 5. The constant term, we don't have one. So that's if you'd expanded it and had anything that didn't have an x with it. And whether or not it's monic, yes. It has a coefficient of -1. And that's fine. That's them, so you'll have to expand those.